Okay, I wanted to pick up a little bit with where we were on Friday and give you some more information. I know we worked on the problem with let's see, which one was it? Oh, yeah, that was, trying to remember. I've done 2 3-act math ones. We did, see, the class did pennies. You guys did the, why am I blanking out? Anyway, sorry, I'm forgetting. So we talked about coming up with formulas for finding arithmetic series, and we're going to do now geometric series. Okay, so we did arithmetic, and now we're going to talk about geometric. So we're going to talk about that today, and then tomorrow we're going to carry it on just a little bit more. Oh, we did the domino skyscraper one. That's what it was. So anyway, we're going to continue with the arithmetic and then do the geometrics. And then I'll give you some problems to work on. Also, you should get your review for your test. That is Thursday. And you can work on that a little bit. Plus, I think you're going to finish your quizzes today. So all things got quite a bit to do while I'm not there. This is going to be relatively short. Let's get the arithmetic one written down that we did on Friday. And we derived this. Okay, and here's how we used it. So we just went ahead and said, hey, if we've got an arithmetic series, then we can find the sum. Okay, here we'll go one more. All right, we can find that sum, make it a little bit more challenging, by using this formula, right? We know we can use our Desmos thing also, but we're going to use this. So I'm going to go n 1, 2, 3, 4, 5, 6 times negative 5 plus 6 times 5 divided by 2 times my difference, which is 2. So here I can cross that out. And look at that, okay? And it's not hard to see, right? But it is going to be 0, okay? So that's how we used it, all right? If you don't know if it's, for example, maybe it isn't arithmetic, maybe it's something else, then you pretty much have to use your summation notation, okay? So we talked about a little bit about summation notation. So this one, for example, would look something like this, right? So it's T1, which is negative 5, plus n minus 1 times 2, right? And then if we wrote that out and put it in, we can get it. Okay, so we can either use the regular Desmos for this, all right, or you can open up and use the document I have for you, right? This has to be in parentheses. Let's see, first one I think was negative 5. I think the sum was 2. So there it is. See how that adds up pretty nicely. Okay. Or you can even use the document, right? So let's go back into this. All right. So there's arithmetic. Let's do a geometric. Now a geometric series formula is a little bit harder to derive, so we're not going to derive it for you. So it goes like this. So we're going to go T1 first of all times 1 minus R to the N over 1 minus R. Okay, so that will give you the sum. So if we have a geometric formula, say something like this, geometric series, sorry, 2, 4, 16 plus 32 plus 64, and let's just go one more. So we're going to add those up. All right, we can use a formula. So we would go S1, 2, 3, 4, 5, 6, 7 equals T1, that's 2. 1 minus, my ratio is 2, okay, to the 7th, parentheses, over 1 minus 2. So, wow, 2 to the 7th. Well, let's see what we got here. So this is actually powers of 2, so it's not too bad. And the good thing about this is our negatives are going to cancel out. And we get that, all right? Now again, we can do this, right? We can go here, okay? As long as we know what the formula is, we can find it out. So 7, I think it was 7, right? So it's geometric. So we know that was the first term, which was 2 times the ratio, which is 2 to the 7th. And let's see, did I get that right? No, n minus 1. Whoops. There we go. 896. Is that what I came up with? No, I just definitely messed this up here. Okay. Well, dummy me put 6 there instead of n minus 1. And now we got it right. Okay. So you can go either way with this, all right, using either the formula or the summation or our document too, because it will also do it, all right. I definitely want to show you how to do some geometrics, okay. There could be a possibility where it wants you to find a sum, but you don't know what term it is, okay. So let's take a look at something like that. So let's say we have 4 plus 7 plus 10 plus 13 plus dot dot dot. $64. Okay, so let's say we have something like that, and we want to know what the sum is. Well, we can use the formula for arithmetic. But the problem is we don't know what n is. And even if we use decimals, we don't know what n is. So we need to figure out what n is. So we need to use that term to figure out what n is. First you have to decide, well, what kind of a series is it? And it's obviously that it's growing by 3, so that makes it geometric. So then you could use this formula, which generates your geometric or your arithmetic terms. It's obviously arithmetic. I probably said geometric. I should be doing this late. But, so anyway, we got 64 here. T1 is 4. Right, and now it's just a matter of working this out. So n is 21. Now that you know what term it is, again, you can use this formula here. And let's see, we're multiplying by 3 because we're going up by 3. Okay, so we do this, and I think I want to cancel that out. All right, so there's our answer. Okay, but we couldn't do it unless we know what n is, and it doesn't matter which way we go. We still got to find n before we can do the answer. All right. Okay, so let's say we have a series like this. Okay, 500 plus 200 plus 80 plus 32 plus dot 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 plus 2.048. And we want to figure out the sum of this. All right. Again, we have to just figure out, well, what kind is it? Is it geometric or is it arithmetic? All right. It obviously doesn't have a constant difference. All right. So maybe it's geometric. Let's find out. So if we take and divide this, you can see that 2/5. Now let's divide this and see if it happens to be the same. So now we have 80 over 20, and that reduces down to 2/5. So we can see that it has a common ratio of 2/5. All right. So let's use, first of all, we don't know. We can use our formula, right, that we have for geometric that we just came up with. Okay, where we take our first term, 500 times 1 minus r to the n. We know what r is. To the n over 1 minus 2/5. The problem is we don't know what n is. So to do that, here we go. So we got to use this guy, right, to figure that out. And we're going to go with this term because that's the last term in the series. Everything else we do know. So now it's just a matter of figuring this out, okay? So you should actually try to work this one out, all right, on your own. So maybe Mr. Mueller could pause this and let you guys play with it for a bit. Okay, let's see if you came up with this. So we're going to divide by 500, all right? So I'm going to go into Desmos here. Let me get rid of this. I'm going to take 500 and, oh, excuse me, not that. I'm going to take 2.048 divide by 500, get 0.000496. See if I can remember that. 0.004096 equals 2/5 to the n minus 1. All right. So we got to figure out what n is, right? So we could solve this equation by a number of different ways. We should know how to solve equations by now. We can do it graphically. We can do it by some sort of algebraic procedure, right? We could use guess and check, certainly. We could try that out, all right? But here's what we got, okay? Well, if we want, since we have a variable in the exponent, we can just use a logarithm on this. And it will work out pretty darn nice for us. All right? Take the log of both sides. That's going to pop out. All right, so let's do that. So I'm going to go into here. I'm going to get rid of this. Come down here. Put in the log. Let's see, what was that number? 0.004096. I'm going to divide that by log of, let me go back and check, 2/5. And I get 8.5. Interesting. Maybe I got a number wrong here. 0.004096. That should have worked out. Hold on, found my little error here. Just 104096. 0.96. Okay, so that's going to make a little bit of a difference. Let's try that out. 6. Yeah, there we go. Okay, so now that we know that this is 6, then n must be 7. So there's our n. Now we can go back up, right? We can go back up and find the answer. We use our sum formula. So we have A1, which is 500, times 1 minus 2/5 to the 7th, right? All over 1 minus 2/5. Okay? So then it's just a matter of putting this into a Desmos or something, a calculator. Hopefully you'll have better luck than I am having here. 500, let's see, times parentheses 1 minus parentheses 2 divided by 5 to the 7th. And then we got to divide that by 1 minus 2 divided by 5. So it should look something like that. We're going to get an approximation because Desmos doesn't give us an exact answer. If we wanted an exact answer, we could do it, all right, by hand. But right now, we'll just take 81.3968. Okay. All right. And again, if we wanted to do that, we just have to take 7 or 2 to the 7th, 5 to the 7th, common denominator, do some work, and we can get a pretty darn good exact answer. Okay. But we'll work on that probably a little bit more tomorrow. So you should be able to either use Desmos or your formulas to find all of the answers to these problems. All right, and then tomorrow we're going to do some more of this type of thing, and then Thursday will be our test. So you have a couple things you can work on. We want to definitely get this started and finished up, and then tomorrow you can do that. So work on that. We're going to add on to it tomorrow. Work on your quizzes. Make sure you get those done. You've got a review you can take a look at. Everything. You got a lot to do today. So I'll see you tomorrow.